Hello students, how are you? Today we will discuss carbon and its compound. A quick revision. Carbon is the sixth element in our periodic table. It's a versatile element. It can form many compounds. Why? Because it is having two important properties. First one is tetravalency, another one is catenism. Tetravalency and catenism. What is tetravalency? Tetravalency means its valency is 4. As carbon is the atomic number of carbon is 6, so it's having electron configuration of 2 and 4. So it can gain 4 electrons and it will follow the octet rule. So it is a tetravalency. Because of the tetravalency, it can form single bond, double bond, as well as triple bond. That's why it can form many molecules. Another one is another important property is that catenation. What is catenation? It's a long chain of carbon and carbon itself. When it can form molecules by combining carbon and carbon chain, that property is known as catenation. Is it clear? So these are the two important properties of carbon. One is catenation, second one is tetravalency. Carbon found only 0.02% in our Earth's crust as mineral and 0.03% in our atmosphere as carbon dioxide gas. Next one is where we will find in mineral form and as well as in atmosphere as carbon dioxide. It can make bond like chain bond. The bonds can be chain as well as a ring form. What is ring form? This is chain form. This type of bonds are called as chain. This type of bonds are called as a ring. 1, 2, 3, 4, 5, 6. Sometimes it is 5, sometimes 3, sometimes 4. It is a closed ring form. It is chain. Ring and chain. Clear? It has some allotropes. Carbon is having some allotropes. What are the allotropes? Let us discuss. Diamond, graphite and fullerenes. First allotrope is diamond. Second one is graphite. Third one is Buckminster fullerenes. Diamond is the hardest substance. Its structure is like this, and graphite structure is like this. This is the structure of graphite, hexagonal, and fullerenes is like a football shape. It is also called as C60 because 60 carbon atoms joined together to form Buckminster fullerenes. It is, as we discussed, it is hardest substance and bad conductor of electricity. It is a good conductor of electricity, but it is a soft one. And fullerenes is dark black, and it is solid at room temperature. Next we will discuss what is organic chemistry. The science which deals with the organic compound is called as organic chemistry. Organic chemistry. What are organic compounds? The compounds which found from our any organ like plant and animals, they are organic compounds. and most of the compounds of organic is C, carbon. Carbon is one of the most important element in organic compound. Except carbonates, carbides, bicarbonates and sulfides, all chemical compounds consist of carbon. Let us discuss types of organic compounds. There are actually many types of organic compounds will be there. We will discuss here only hydrocarbons because in class 10th hydrocarbon is there. Okay, let us discuss hydrocarbon. Hydrocarbon and others are there. Haloalkanes in 11th and 12th we will discuss. Alcohols, ketones, aldehydes, then carboxylic acid, amines, ester and ethers are there. Let us discuss hydrocarbons. Hydrocarbon, hydrogen plus carbon, it is hydrocarbon. Hydrocarbons are categorized, if we will categorize, then two types: saturated and unsaturated. Unsaturated. Saturated, single bond. All single bond molecules are saturated. Its formula is CnH2n plus 2. Here unsaturated, two types: double bond and triple bond. Here double bond and triple bond. For double bond the formula is CnH2n. Here the formula is CnH2n minus 2. So you have to remember these formulas: CnH2n plus 2, CnH2n, CnH2n minus 2. From this formula we can find out if number of carbons will be, we know the number of carbons, then we can find out the number of hydrogen atoms in hydrocarbons. Is it clear? Here in single bond, one more thing, single bond, the suffix will be ane, here ene, here yne, ane, ene and yne. For example, when we will do the naming, if number of carbon atom will be 1, then it is meth, 2 means eth, 3, 4, 5, 6 like that, 3 prop, 4 but, 5 pent, 6 hex, like that, so on. Okay, if it is a single bond, then we can write methane. If it is a double bond, we can write ethene. If it is a triple bond, yne, propane, methane, ethene, propane. Is it clear? It is single bond, it is double bond, it is triple bond. When the carbon atom forms triple bond, it is propane. The suffix will be yne. The suffix will be here ene. Here the suffix will be ane. And one more thing we have to remember is that for double bond and triple bond, it will start from 2 onwards, not from single. Single carbon cannot make double bond. Why? Because this is the structure H. This is methane. I have done the structure of methane. If we will do this ethene, then I will go like this. I will do like this, C and C. Okay, H and H. This is ethene. If we will propane, same thing, 1 triple bond will be there. So is it clear now? In hydrocarbons, how we will name the compounds? Naming is very important. This will come in your exam. Definitely it will come in your exam. First one is, there are some groups. First one is halogen group. We have to remember the halogen group. Okay, in halogen group, what are there? Chlorine, chlorine, iodine, bromine. Chlorine, bromine, and iodine. If out of these four, anything will joined instead of one hydrogen atom. Let us take an example. I will take this one. This is the propane. H, 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 H. Look at here the general formula. General formula already we know that CnH2n plus 2. See, 1, 2, 3 carbons are there. Number of carbons 3. So how many hydrogens will be there? 2n plus 2. 3 into 2 plus 2. 2 into, sorry, 2 into, sorry, yes, 2 into 3. 2 into 3. 6 plus 2 is equal to 8. Find out 1, 2, 3, 4, 5, 6, 7 and 8. If carbon will be 3, hydrogen will be 8. What happens here? If instead of this hydrogen, one chlorine will be there. Chlorine. Then the naming will be changed. It is first it was when it was H is there. At the time it is propane. Now it is propane. Now it will become chloropropane. Chloropropane. Chlorine is attached here. Halogen group. If it is bromine, bromopropane. If it is iodine, iodopropane. Is it clear now? Next one is alcohol group. Alcohol group, alcohol. Second one is alcohol. Alcohol group, same thing. OH will be there. If OH will be present, same structure we will take CCC, HHH, all H, same structure we will take. Instead of this H, if it is OH, instead of H, OH will be there, then it will become propanol. Propanol. OH means it is alcohol. Next one is aldehyde group. Next one, aldehyde. Aldehyde group. In aldehyde group, it is CHO. CHO. In CHO, what happens? Look at here. C 1, 2, 3, 4, 5, 6 is there. CHO. C, here it is H. This will become CHO. It is aldehyde. Then what will happen? The name will change, propanol to propanal. Propanal. NaL. Clear? Now we will go for ketone. Ketone. Ketone is CO. Ketone is CO. But see, the structure will remain same. Aldehyde and ketone, the formula will be same, but structure will be different. O cannot be present here. If O will be present here, then it is aldehyde. If O will be in middle anywhere, then here it can be O. Clear? It is ketone. Propanone. N-O-N-E. N-O-N-E. Very simple. Propanone. Now it is carboxylic. Carboxylic. carboxylic group. COOH. If the group will be COOH, then we have to erase all these things. H, H. Okay, it is COOH. CO, another OH will be here. So it will become COOH. What is this? COOH. We will read like the COOH, carboxylic group. If it is carboxylic group, then we will write propanoic acid. Propanoic acid. Clear? Double bond, triple bond already over. If double bond will be present, then propene. If triple bond will be present, then it is propyne. Clear? So from this, one question will come definitely. Be careful. Next one is that one sure shot question will be there. What is isomer? Isomerism. Isomerism means what? The structural formula will be same, but structure will be different. For example, suppose we will take like this. H, 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 H. We can write it like this, and we can write like this also. C, C, and C. Another C. H, 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 H. It is a C. H, H, H. So you can count. The formula is, molecular formula is same, but structure is different. Structure will be different and molecular formula will be same. It is called isomerism. This will come in your exam definitely. How many isomerisms can be formed here? So look here, how many carbons are there? 4 carbons. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hydrogen is 10 here. Here also carbon 1, 2, 3, 4. Carbon 4. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So molecular formula same, but structure is different. So it is called isomerism. Clear? Just remember that this will come in your exam. Definitely it will come in your exam. Next one is, we will discuss some chemical properties of carbon compounds. Some chemical properties. What are the chemical properties? From these chemical properties, definitely one question will come. First one is combustion. Combustion. Combustion means when something combusted, burns. Carbon burns in presence of oxygen. We will get carbon dioxide plus heat and light. This is combustion. Next one is oxidation. Next one is oxidation. Suppose we will take CH3CH2OH. CH3CH2OH in presence of KMnO4. We will, oxidation. Oxygen will be added here. 2O will be added here. Okay, in presence of KMnO4 or K2Cr2O7. K2Cr2O7. Here this one is either this one or this one. This is basic in nature and this is acidic in nature. They are called as KMnO4 potassium permanganate, or this one K2Cr2O7, that is potassium dichromate. They both are oxidizing agents. Those who are helping in oxidation, they are called as oxidizing agents. In presence of KMnO4 or K2Cr2O7, when we will CH3CH2OH will be treated with this one, with the 2 oxygen will be added. What we will get? CH3COO, CH3COO, CH3C OH plus water. We will get water. Clear? It is potassium dichromate. Dichromate. Here basic and acidic both are acting. Alkaline. It is alkaline nature and it is acidic in nature. Clear? Now we will discuss addition reaction. Very important oxidation. Oxidation reaction is very important. Now addition reaction. Addition reaction. In addition reaction, unsaturated hydrocarbons add hydrogen in presence of catalyst like palladium. So here C unsaturated, this might be double bond or triple bond. C H H H H. Okay. In nickel catalyst, we can take nickel as a catalyst. Okay. H2 will be treated. Then what we will get? We will get here saturated hydrocarbon C and C, H H H H H H. From unsaturated hydrocarbon ethene to ethane. Unsaturated hydrocarbon, it is ethene to ethane. What happens here? This H2 will be breaking here and this one H will be added here, another H will be added here, and this double bond will break and it will become single bond. But nickel has to be present as a catalyst. What is a catalyst? Catalyst increase or decrease the rate of reaction, increases the rate of reaction. They do not involve in the reaction, but they increase the rate of reaction. Next reaction is substitution reaction. After addition, substitution reaction. Substitution reaction. In substitution reaction, actually saturated hydrocarbons are unreactive, but sometimes in presence of chlorine they reacts and chlorine can be added and hydrogen will be removed. Suppose I will take methane CH4 plus chlorine in presence of sunlight. If sunlight will be present, then what will happen? One chlorine will attach here, CH3Cl. We will get CH3Cl and one H will convert here and we will get HCl. Is it clear? In presence of sunlight, saturated hydrocarbons can be react. Okay. Now we will discuss some important, out of this 4 reaction, one reaction will come definitely. So go through this all reactions. Next one is some important carbon compounds. In our book it is ethanol and ethanoic acid is there. Ethanol. First one is ethanol, second one is ethanoic acid. So first we will discuss ethanol. What are the properties of ethanol? It is used in tincture iodine in medical cases and it is used as alcohol, any medicine, cough syrups, we are using alcohol. Reactions of ethanol. First we will discuss what are the reactions of ethanol, how it reacts. Reactions of ethanol. First, how it reacts with metals like sodium, 2CH3 CH2OH plus 2Na. What will happen here? It will one Na will and this H will remove from here. H2 as will remove from here. So what we will get? 2 CH3 CH2 O Na plus H2 gas. Clear? O Na, here Na is plus, O is minus. Clear? What happens? this Na will go here and it is attached here, and this H will remove from here. 2Na will go here and 2H will be released. So we will get 2CH3 CH2O minus Na plus H2 gas. Next one is CH3 CH2OH plus. Suppose we will just add some sulfuric acid. If we will treat with any acid, let us take sulfuric acid, then how it will react? It will become ethene, CH2 CH2 plus H2O, water we will get. From here, alcohol to, how can we prepare alcohol to unsaturated hydrocarbons or ethene? This is the reaction. When we will treat with the acid, then we will get ethene. Clear? Next one is, this is the reactions of ethanol, reactions of ethanoic acid. Now we will do ethanoic acid. If 5 to 8% of ethanoic acid will be added in water, then it will become vinegar, and its melting point is very low, 290 Kelvin. So it can be freeze very easily. In winter season, sometime it freezes, frozen, and that's why it is called as glacier acetic acid, carboxylic acid, glacial carboxylic acid. Now we will discuss some reaction. First one is esterification reaction, very important. Esterification, remember, this might come in your exam. Esterification reaction. What is ester? Actually, esterification reaction means the chemical reaction that takes place during the formation of ester is called esterification reaction. Ester means what? It is a fruity smell structure. Ester we will prepare from ethanoic acid. From ethanoic acid to ester, CH3 COOH. It is ethanoic acid. When it will be treated with ethanol, CH3 CH2OH, CH3 CH2OH in presence of concentrated H2SO4. Concentrated H2SO4, we will get ester. What is ester? CH3 COO plus C2H5. This H will remove from here. Okay, CH3 CH2. Is it clear? CH3COO, I wrote here CH3COO, then CH3 CH2 will go here and this H will be replaced and it will become H2O. H2. This is a complete reaction. In book it is only up to here it is given, but H2O will be there. Clear? This is what? Ester. This is ester. This one is CH3COO, CH3CH2 is ester, or C2H5 also you can write, no problem. Clear? From ester we can get back, again we can get back alcohol. This is called saponification reaction. Esterification and saponification, that will that is must, we have to remember that must, because it will come definitely 90% sure that it will come in your exam. CH3 COO C2H5. When it will be treated with NaOH. Here, look at here, what is the difference? Here we are treating with concentrated H2SO4, here base. Acid, here base. When it will be treated with base, we will get again ethanol, C2H5OH, ethanol. Clear? Plus CH3 COO 1Na, whatever left you write that one. Okay, this is sodium acetate. This is sodium acetate and alcohol, ethanol. We are getting alcohol, ethanol, as well as sodium salt. Sodium salt, this why it is called a saponification reaction, because it is used, this is used to prepare soap. Clear? Now reaction with the base. Esterification and saponification, this is very important. Let's go through it. Next one is reaction with base. Reaction with base. Same reaction will occur, CH3COOH, CH3COOH plus NaOH. Base means NaOH. Same reaction will occur. What we will get? H will be displaced from here. CH3COO Na plus H2O. This is reaction with base. Now reaction with the carbonate. Reaction with carbonate. Reaction with carbonate, 2CH3COOH plus sodium carbonate. Let us take sodium carbonate, Na2CO3. Na2CO3. Then what we will get? Na will go here and H will be displaced. Clear? So we will get 2CH3. What is here? 2CH3. Okay, COO. Already I told you this H will be removed from here and Na will be attached here. COO Na plus H2O plus CO2. Clear? Next reaction is with reaction with hydrogen carbonate. Hydrogen carbonate. Same thing, CH3COH. Same reaction will occur, CH3COOH plus NaHCO3. NaHCO3. This H will be removed and Na will displace this H. Then what we will get? CH3COONA plus what we will get? H2O plus carbon dioxide. Same reaction. H2O plus CO2. Clear? Clear? Let us discuss soap and detergent. Soap and detergent. Soap and detergent. Actually, soap, already I told you, already we discussed that saponification reaction is used in the preparing soap. Okay, same reaction will occur, but here sodium and potassium salts are used while preparing soap. And in detergent, little bit different. In detergent, we are using ammonium or sulfonate salts. That is the basic difference between the soap and detergent. Okay, clear? What happens? Soaps are used to clean clothes or anything. If any dirt will be present there, suppose this is the dirt here in our cloth. Okay. Actually, in soap molecule, there are two ends like this. Okay, this is the molecule of soap. This is positive end and this is the tail. Okay, this is called hydrophilic end, hydrophilic, and it is hydrophilic. It is this end is called hydrophobic. Actually, hydrophobic end and hydrophilic end, what is the difference between hydrophilic end and hydrophobic end? It is soluble in water. This is soluble in oil. So what happens? All darts are actually oily products, oily things. What happens? Suppose this is the dart in our cloth. What happens when we dissolve that cloth in a soap? Dissolve in then what happens? This is okay. This is positive end. This is the cloth, dirty part of our cloth. What happens? this will not dissolve in water, this will dissolve in water. So when it will dissolve in water, it will try to go up. Clear? It will dissolve in oil, this part will dissolve in oil. Already we know that dirty things are oily things. Oil can dissolve in this hydrophobic. So what happens is hydrophobic end will dissolve in this that, and this will float. Well, it will float, this particular point will float. Then what happens, automatically that dirtiness will vanish from our cloth. Is it clear? So basic difference between soap and detergent is, soap is sodium and potassium based salt, while uh, mm, while detergents are ammonium based or sulfonate based salts. I think today's class would have been helpful to you. Thank you. Have a nice day. Next time again we will meet in our next class. Thank you.